Hello, question number 30. It's it reads, consider two identical cylindrical vessels, one filled up to a height h, which is 1 meter, by a large number of plastic beads, and the other filled up to the same height by water. This is the picture. Total mass of the beads is 500 kg, and that of the water is 1000 kg. If all the water is gradually transferred in the first vessel, find height attained by the top layer of the beads. Density of the plastic beads are known to us, and that is of water is also known to us. So these are two identical containers up to height h for both. One is filled with the beads, another filled with the liquid water. Now this water is being transferred to this container, and then we need to find up to what height these beads goes to. So situation will be some sort of this. Now since bead has a lesser density as compared to water, so it would like to float in this. So there will be three junctions we can think of. At the bottom there will be water only, and there will be some intersection in which you will find the beads and water will be present together, and there will be some portion where will be beads only. So let's call the height in which beads only are available is h1. The common height where these two are present is h2, and the downward height in which purely water is available is h3. Now what we need to find is h1, h2 and h3, the sum of all three. So we need to find this height. Now here I have written something, let me explain. So since density of beads is less than that of water, I just explained, therefore beads will remain arranged in same manner even after transferring the water. So even after water comes, you will find this will be intact, which means h1 plus h2, the total height of the beads will be the same as it was original. That means bead will not leave the contacts, and they will be arranged in the very same manner, but they will not be at the bottom, they will be somewhere at height. So h1 plus h2 must be equal to h. This is what we can say because we will say this water is going to fill up at downside, then it will be pushing them up like a single body. Now let's consider the case of the water. What happens to the water? Water will be occupying some volume downside and some volume within these beads. So total volume will remain the conserved, as well as we can say the total mass will remain the conserved. So mass of the water remains same. So total mass is going to be density of water cross-sectional area, let's say that is A into H, the height, the original one. And the same mass could be written as density into that mass present in H3 height, so density area into H3, so that is the mass present in this H3 height, plus the mass present within these beads or voids of these beads, right? So density is rho naught, and let's say the water has a volume VW, which is present in this H2 height. Now we know if we talk about this H2 height volume, this volume is going to be AH2, total volume, and this volume will be occupied by two materials. One is water, another is bead. So we can say that this volume will be some of the two other volumes. The volume of water which we have talked about, this VW is basically inside this, so one segment is going to be VW, and the rest of the volume will be occupied by the beads. Now beads, let's say total beads volume is V, total volume is V. So for bead, let's consider the total volume is V. So we can write the total mass is equal to density of bead into total volume. So total volume turn out to be mass of the beads divided by density of the beads. Now this volume was distributed on height h. And since this arrangement is intact, that means up to height h2, how much the volume will be. So this V volume is corresponding to height h. Therefore, for h2 height, the volume of beads will be V divided by h into h2. So this will be the fraction of the volume which will be in the fraction of heights. And this will be occupied, this is the volume occupied by the beads in this h2 height, and this is the volume of water present in this h2 height. So these two together gives the total volume of this h2 height. That means we are doing volume conservation, right? Now from here we can find out this volume occupied by the water, that is going to be AH2 minus VH2 divided by H. Now this VW can be substituted over here to make this one equation, another equation, right? And for bead we have talked about this thing. Now from this equation we can write this A, because area of these containers were not given, so A can be written as m divided by rho naught into h. Moreover, we can rewrite this equation, which is this m is equal to this number, which is rho naught AH3 plus rho naught into VW. VW can be written as AH2 minus VH2 by H. So AH2 minus VH2 by H. So this total together gives the total mass of the water. I hope you are there. So if you are, we can carry with it. Now what we can do is this, we can replace this rho naught A. So this rho naught A is basically capital M by H, or we can put the value of A, both are the same thing. So rho naught A is capital M by H, so capital M by H into H3, so that's first term, plus if you open this, so again rho naught H can be written as M by capital S, so M by capital H into H2. So here you will find H2. Now we need to find this H2, that means height of the second. We can do one more thing. Let's pause over here and talk about these beads. These beads have been lifted, so if you draw the free body diagram of these beads, you will find there will be force balance, right? So total weight of the bead will be acting downward, and the force that is holding these beads is upward force, buoyancy force. Now how much the buoyancy force will be acting? So buoyancy force must be balancing the weight of the beads. Buoyancy force is going to be equal to the submerged volume of the bead into the water. Submerged volume of the bead into the water is within this H2 height. That is basically this fraction. So that is VH2 upon H that we have already calculated. This is the volume of beads within water into the density of water, which is rho naught into G, that's the buoyancy, M into G, that's the weight. So G getting cancelled out from here. H2 can be calculated, will turn out to be let's write over, this is going to be MH divided by V rho naught. V is M by rho, so M and M getting cancelled out. Ultimately it turned out to be rho H upon rho naught. So you can check this calculation. So height H2 we are able to find. This height H2 comes out to be rho H divided by rho naught. And once you got to know this H2 can be substituted on this expression. If we substitute here, so that will be basically H2 is equal to rho H upon rho naught. So this came out to be H2, which is rho H upon rho naught, minus this number. Now if you look at this number, which is basically rho naught VH2 upon H, rho naught VH2 upon H. If we cancel G, so that equal to the mass of the bead. So this becomes total mass of the beads is equal to capital M. So I have used these calculations, so in these calculations, and I have explained how I have used. You just focus and revise. Now from here you will find we can count this H3, because this H3 is the only unknown and rest numbers are known. And of course this H we need to find out, so H is also unknown. So H3, this total height is known. Okay, so H is something that is known to us. Fine. So H3 from here can be written as capital M. This came here, so that becomes small m, and this term came here, so that becomes minus H getting cancelled out, capital M rho upon rho naught. And when we are writing H3, so this small h by capital M has to come as a product. Now this capital M can be taken inside, so H3 is coming as small h within bracket 1 plus small m by capital M minus rho by rho naught. Now we need to find the total height, or the height up to the beads go. That means we need to find H1 plus H2 plus H3. We know H1 plus H2 is H, and we have calculated H3. That was the purpose basically. So H1 plus H2 plus H3 came out to be as H plus H3, which is here, that I have said that H within bracket 1 minus rho upon rho naught plus small m by capital M. Now if we take this H common, so this 1 plus 1 becomes 2. So answer becomes total height is equal to H within bracket 2 minus rho upon rho naught plus small m by capital M. Now if you look carefully, all these numbers that we require are given in this question. So we can put their numerical values. So this is our answer in terms of expression. In numerical, you'll find H is equal to 1 meter. So I can substitute here. 2 is 2. Rho is 800 and rho naught is 1000, so that turned out to be 0.8. Small m is 500 and this is 1000, so that turned out to 0.5. This will be minus 0.3, so 2 minus 0.3 is 1.7 meter. So total height up to which these beats rises is 1.7 meter. That's our final response. Okay, thank you.